Hello everyone. Today we'll discuss about work done. Okay. Today our topic is work done. Work done. See, first thing is that what is work done? Suppose here one object has been kept on a floor. Okay, this is the object. Here, if we will apply a force F on the object, and if the object will displace its position, means suppose it is displaced up to here, it has been displaced to here, okay, then we say that we have done work. Clear? So work done W equals to, we get force F into displacement S. That means that is W equal to F S. This is the formula of work done. Clear? Now, what will be the SI unit? SI unit of work. So, what is the SI unit of work? We know that W equals to force into displacement. Clear? So, what is the SI unit of force? We know that SI unit of force is Newton and displacement is meter. So we get Newton meter. This is also known as joule. Here, this is also known as joule. So from here, if we want to give the definition of joule, then what we'll say? That means 1 joule equals to 1 Newton into 1 meter. That means if we will apply 1 Newton of force, means here if we apply force is 1 Newton. Here if we will apply force is 1 Newton, and then the body has been displaced up to 1 meter, then the work done is said to be 1 joule. So this is our definition. So again I am saying what is the definition of joule. If we will apply 1 Newton of force on an object and the object has been displaced up to 1 meter, then the work done is said to be 1 joule. So this is our definition. Clear? Now as force and displacement both are vector quantity, and work done is a scalar quantity. So how? See, work done W equals to force, vector force dot S, means we have to take dot product. We know that the product or result of a dot product is a scalar quantity. That's why work done is a scalar quantity, though force and displacement are vectors. Clear? So W means work done equal to F dot S. If we remove the dot product, then we will get Fs cos theta, where theta is the angle between F and S, means force and displacement. Here you see, if force and displacement have an angle theta, then W equals to F dot S equals to Fs cos theta. Now there are 3 types of work done. Now work done are of 3 types. One is positive work done, one is negative work done, and another one is zero or no work. Zero work done or no work. Wait, I am showing here. The physics of work. One is positive work, another one is negative work, and third one is zero work. See, one by one, I am going to discuss. First one, I am going to discuss positive work. So, what is positive work? See, positive work means if we'll apply on this object force here this way, means right hand direction, and the body has been displaced in the same direction. That means if we apply a force on an object and the object has been displaced in the same way, suppose in this on this object, means this pen, okay, if we apply the force towards this direction, means this direction, if we apply the force and the body also displaces same direction, then the work done is called positive work done. Here the angle between the force and displacement is 0 degree. Why? As force and displacement are parallel, okay, are having the same direction. That's why theta, means angle between force and displacement, is 0 degree. So cos theta equals to cos 0 degree equals to 1. We know that value of cos 0 equals to 1. Therefore, work done equals to Fs cos theta equal to Fs cos 0 degree equals to Fs into 1. Fs into 1. That means we get W equals to Fs. This is the positive work, and this is the maximum. This is the maximum value of work, or W. Positive work done, the maximum positive work done is Fs. Second one is negative work. For negative work, the value of theta will be 180 degree. How? Suppose if we apply force towards right hand side direction and the body displaces left hand side direction, that means the displacement is towards left, and applied force is towards right. Here, so angle between them, so what is the angle between them? Force and displacement, it is 180 degree. Clear? This is 180 degree. So here theta equals to 180 degree, cos theta equal to cos 180 degree. We know that cos 180 degree value is minus 1. The value of cos 180 degree is minus 1. So W equals to Fs cos theta equals to Fs cos 180 degree equals to Fs into minus 1. So we will get W equals to minus Fs. This is the negative work. This is the formula for finding negative work or negative work done. Clear? Third one is zero work done or zero work. For zero work, the angle between the force and displacement will be 90 degree or perpendicular. They are having the angle between them are 90 degree. So 1 minute. I'm just rubbing the board. Here you see our zero work. For zero work, suppose we are having the object, we are lifting the object towards upward direction, we are applying force to lift an object and its displacement is towards right. Clear? Means vertically we are applying force and horizontally the body has been displaced. Then the angle between force and displacement is 90 degree. What is the angle between the force and displacement? It is shown as 90 degree. Then see, work done will be F S cos theta. Here theta equals to 90 degree, implies that cos theta equals to cos 90 degree will be 0. The cos 90 degree is 0. Therefore, W equals to Fs cos 90 degree equal to Fs into 0. Therefore, we get W equals to 0. This is called 0 work done. One example I can give. Here you see that example for 0 work done. Suppose I am carrying of the things, any object like this way. So here gravitational force is applying towards the downwards direction, and the object is moving horizontally. See, so here I am doing no work. This is one of the example of 0 work or 0 work done. Clear? Now, some examples of work done in physics are given. That changing position or displacement, if any object, by applying a force, if any object will displace or change its position, then we can say that work has been done. Here some examples are given. A man pushing a box and moving it from location A to B. From A to B, this box has been moved. That means that man are doing some work. Similarly, a crane tow a broken car and takes it to a workshop. Means that crane can moving a broken car from one position to another position. That means that crane also doing some work. Here, changing speed or direction. If by applying a force, if we can change the speed or direction of an object, then also we can say that work had been done. Suppose one example, in a school football match, when a boy hits a ball to dodge another player. Okay, that means that football has been displaced its position. That means the boy has been done some work. Similarly, a batsman hitting a ball during a cricket match means its directional speed of the ball has been changed. That's why that batsman has done some work. Similarly, change in shape or size. If any object, by applying force, if we change the shape or size of an object, then also we can say that by the force we have done some work. Suppose a compressed spring, when released, does work on a ball. Suppose if we compress the spring and if we keep a ball over the spring, and if we release the spring, the ball will jump over. That means the spring has been done some work. Similarly, kids sitting at a place and making different shapes of objects with the help of plasticine. They are doing work because they are changing the shape of the plasticine. Means with the plasticines or clay, if they will make one object, okay, any playing object, that means the children also doing some work. So these are the some examples of work done that is happening in our daily life. Clear? Next we'll discuss more about that work done, okay, in our next part. So till for today, I think it is enough for today. So next day, in next part, we'll discuss more about on the work done. Okay, student. So today only for it is enough. Thank you and goodbye, everybody.